Another triangle property is the Pythagorean Theorem. Now this only works with right triangles, and what a right triangle is a triangle that has a 90-degree angle as part of it. So some terminology that we have, these two side lengths, little a and little b, these are each called legs. And let's go ahead and call that leg 1, leg 2, and then the one that's different, the side length C, which is the longest side of the right triangle, is called the hypotenuse. And the hypotenuse, if you have a hard time seeing it, it's always opposite the 90-degree angle. So it's the one that's not touching that right angle as part of the triangle. Now, if we have that setup of we have a right triangle, then we have a rule that works with our side lengths that little a squared plus little b squared is equal to c squared. And really, the main trick with using this formula is that you have to make sure that it's the hypotenuse that's alone on one side of the equation. So the order of the legs doesn't matter, but what does matter is that you have the hypotenuse squared is equal to each of the legs squared. So we just want to make sure that the legs go on one side, hypotenuse on the other, and the hypotenuse needs to be alone. Okay, so let's try this out in some different ways of solving. So this first one, we're missing a side length here. Let's go ahead and call that x. And what we'll have is, we'll put the hypotenuse alone on one side squared is equal to, and then we'll have 16 squared plus 24 squared, which x squared would then be equal to, let's get our calculator out. So 16 squared plus 24 squared is 832. And then to finish our solving, we'll take the square root of both sides. And when we do this in algebra, we typically have plus or minus. So we'd have like x equals plus or minus whatever that square root is. However, since we're dealing with context and these distances, we'll always have positive. But I just always want to mention that because we'll get to a point where it's very important to have the plus or minus. So I'll keep mentioning it, but in terms of word problems, we'll just have the positive. And we are taking the square root of 832, which is about 28.84. And then we'll just use our units, which are in centimeters. And then to kind of check my math, what I make sure is that that is in fact the longest side length, especially when we're solving for the hypotenuse. So with that, we can compare it to the others, and it is in fact the longest. Okay, another scenario. So we are actually given the hypotenuse. So again, I kind of start by just seeing, okay, there's our hypotenuse. So I know that that has to go alone on one side of the equation. So 7.125 squared is equal to, and then we have a given leg, and then we have a missing leg. So we're going to have our x squared plus 6.75 squared. So to solve for x squared, what we'll have is the hypotenuse squared minus the leg squared. And then we'll be taking the square root. Because of those decimals, I'm just going to plug this in all at once to keep it as accurate as possible. So let's grab our calculator, and we'll have a big square root with underneath 7.125 squared minus 6.75 squared. And that's a 2.28. And our units are in inches. So we're all good to go there. And I do that quick check again that the hypotenuse is in fact the longest side length, and it is. Okay, last quick example here, a little word problem. So we have Aisha, usually walks home around the edges of a local park. One side of the park is 2.1 miles, the other side is 1.4 miles. How much distance would... That's not English. So, sorry, some typos there. But we are going to find the distance of the diagonal of the park. So Okay, here's our park. And what Aisha's going to do is usually she goes 2.1 miles, 1.4 miles. But now what she's going to do is cut across diagonally, and we want to know what is that diagonal. So we have our right angle, so we know we have a right triangle, so we can use the Pythagorean theorem, and it will be hypotenuse squared is equal to 2.1 squared plus 1.4 squared, and then we're going to take that square root of both sides so that we're getting x equals, and then we'll go to our calculator, which we would be taking square root 2.1 squared plus 1.4 squared, which is a 2.52. And that would be in miles. So how much, okay, I can figure out what's trying to be said here. So we want to know how much distance is she saving by going diagonal versus going around the park. So typically she travels the 2.1 miles plus the 1.4 miles. So usually she's going 3.5 miles, but now the new distance is 2.52 miles. So what we could do is really it's a difference of about 1 mile. Wow, that's a big park. So that saves a good amount of distance, about 1 mile shorter to go diagonal as compared to going around the park.